A system pictured below has a hanging mass of m2, which is mass 2, which is equal to 2.0 kilograms, and a mass on an inclined plane, m1, which is equal to 3.0 kilograms. Part A, draw free body diagrams, and Part B, if the surface makes a 28 degree angle with the horizontal and has friction coefficients. Static friction equals 0.27 and mu kinetic equals 0.21. Find the tension in the string. So let's start with Part A, which is to draw free body diagrams. In this system, there's two masses, so that means we can draw two free body diagrams. So let's start with mass 1. The first thing you want to do is draw the mass and write out what the mass is inside the box. So in the question, we see that for mass 1, it's equal to 3.0 kilograms, so we can write that inside the box. And now we gotta find all the forces that are acting on this box. So first of all, there's a force of tension pulling it to the right from the string. And then to the left, there's a gravity force that's pulling it down. And on top, there is a normal force that's perpendicular to the surface. So the surface is here, and then perpendicular to the surface, that's the normal force. Now, since the question is giving you, in Part B, the coefficient of friction, we can assume that there's a friction force. Now, should the friction force go to the left or to the right? To be honest, I'm still not very sure about this, but in general, in these questions, friction is to the left. Generally, in these questions, the whole system moves this way, or it could be stationary, or it could be going this way. It could be going in this direction. But in general, the system goes to the right. So then friction opposes the direction of motion, so that's why in this case it's to the left. Now, for M2, let's draw it here. In the question, it tells you that it's 2.0 kilograms. So what are the forces acting on this block? Well, there's a force of gravity that's pulling it down. And there's a tension force that's pulling it up. So this is the answer to Part A. Now for Part B, if the surface makes a 28 degree angle, it's telling you to find the tension in the string, but it's giving you mu s and mu k. So which one should we use? Well, first of all, let's calculate the net force of this system only using the force of gravity. So we're going to ignore tension force, and we're going to ignore friction force, and we're only going to calculate the net force that gravity is acting on the system. So let's start with Let's start with the force of gravity of M2, since we expect that to be bigger than M1, because usually in these problems, it's the whole system's moving in this direction. So the formula for the force of gravity is mg. In this case, m is 2.0, and gravity, that's always just 9.8. And let's see what we get. It's 19.6 newtons. Now let's calculate the force of gravity on mass 1. Well, in this case, it's not going to be mg, because for mass 1, Fg, it's pulling it in this direction. So what we want to do is to draw a triangle like this. This is a right angled triangle, and this angle here is 28 degrees. And this line over here is equal to mg. But that's not what we want. We want this portion of it, since that's the direction that the force of gravity is pulling it. So basically what you want to do is use your trig ratios, and you'll get mg, and since this red force of gravity is opposite to the angle that we know, we're going to use sine. So I'm writing mg first because that's the hypotenuse, and then all we got to do is multiply that by sine of the angle, which is 28 degrees. So the mass of object 1 is 3.0 kilograms. G is just always 9.8 times sine 28. And let's see what we get. The answer is approximately 13.8 newtons. So we can see that if we disregard the tension force and the friction force, we see that the overall system is moving this way, since this number is bigger than this number. And now what we want to do is to calculate the net force based on only the gravity. So F net equals, and since we know it's going in this direction, we can make this part positive and then we can make going in this direction negative. So F net equals FG M2, and we're always going to add it in the first step, but we can subtract it in the second step. M1 equals to 19.6. This is positive since it's going in the positive direction, and this is going to be negative since it's going in the negative direction. And if we subtract it, we get a net force of positive 5.8 newtons. So that means that if there's no friction, then the whole thing would just be moving in this direction with a force of 5.8 newtons. Now, we don't actually know whether the system is moving or not, because there's friction, and the friction could potentially be larger. The force of friction could be larger than the net force. And if this happens, that means that the system is not moving and it's just stationary. So let's find out if the system is moving. And we can do that by calculating the force of friction on M1 just by using the static mu. So let's find the force of friction. The formula for the force of friction is mu times the normal force. And in this case, we're going to use mu s. So we're using mu s because we don't know if it's moving or not. If we know that it's moving, we can just use mu k. But if it's not, we have to try it with mu s and to see if the total force of friction is going to be less than the net force. If it's less, then that means we can use the kinetic mu. But if it's more, that means it's not moving, and the force of friction is making sure that the system is not moving. So mu s is 0.27. And Fn, that's the normal force. And the normal force is going this way. And the normal force is equivalent to this part right here. And to get that, we can use trig ratios again. We're just going to do it the fast way and do the hypotenuse, which is mg. And in this case, the normal force is adjacent to the angle. So we're going to use cosine, and the angle is 28 degrees. Okay, and let's see what we get. (0.27), the mass is 3.0 times 9.8 times cosine 28. And we get 7 newtons. As you can see, the force of friction it's larger than the net force. So that means the whole system is going to be stationary. So it's actually not going to be moving. If the force of friction was less than the net force, that means the net force would make it move even if there was friction. So whenever there is something that is not moving, that means F net equals 0. And we're going to use F net to find the tension in the string. So to find the tension in the string, you have to realize that the tension in this string is equivalent to the tension in this string. It's the same thing. So that means you can just choose one of the two objects to find the tension for. And the easier one would be M2, since the only force acting on it is gravity and tension. If you choose M1, well, you're going to have to worry about the force of friction, as well as gravity and tension. So let's write an equation for the net force of M2. F net equals, well, we're not going to do MA because we know that acceleration is 0. So for example, if you did MA, then it would F net equals 0. And F net, we can replace that with the forces acting on M2, which is the force of gravity and plus, even though it should be minus since it's moving in the opposite direction, Ft. So let's plug in what we have. So the force of gravity of M2, well, that's the mass times 9.8, which is 19.6. And since the tension is going in the opposite direction, we're using minus. And as you can see, 19.6 minus what is going to be equal to 0? Well, if Ft is equal to 19.6, the whole net force is going to be equal to 0. So the answer to this question is 19.6, and you'll realize that it's actually the same as the force of gravity. And that's because F net equals 0, so forces in the opposite directions, they have to add up to 0. So 19.6 plus negative, since it's in the opposite direction, 19.6 equals to 0.